be a source of energy. It is a source of charge. No, it is not a source of charge. It is not a source of charge. Okay, let us say that I am having a circuit. Let us say that this is a circuit. Let us say that this is a bulb. Okay, so this is a bulb. Okay, now if this bulb has been connected to a battery is represented by the symbol of this, where the bigger line represents the higher potential and the lower one represents the lesser potential. Okay, now so if I say that this bulb is connected to a battery, so definitely this bulb is energy, a source of energy. You will say no, so it cannot be a source of energy. It is a source of charge. No, it is not a source of charge. It is not a source of charge. Okay, let us say that I am having a circuit. Let us say that this is a circuit. Let us say that this is a bulb. Okay, so this is a bulb. Okay, now if this bulb has been connected to a battery is represented by the symbol of this, where the bigger line represents the higher potential and the lower one represents the lesser potential. Okay, now so if I say that this bulb is connected to a battery, so definitely this bulb will start to glow. Let us say that the bulb will start to glow. So you will say that the battery is providing energy. The battery was having chemical energy stored in it, and that chemical energy is now getting converted into the light energy. Perfectly, I understand. But can I say that here actually current was flowing? What was flowing? Current was flowing. Okay, and the value of the current is rate of flow of charges. Okay, current is basically the number of charges flowing per unit time. Okay, so if I say that the battery is the one that is supplying the current, okay, so you will say that the battery is not the one that is supplying the charge. Okay, the battery is not the source of charge. Its function is to maintain the charge. Its function is to maintain the charge. Okay, now what has happened here? Well, how does maintenance of charge take place? So let us say that the charges here you can see that the positive charges will be accumulated here, negative charges will be accumulated here. Okay, so definitely electron will move from the lower terminal. It will gradually go, and it will, like this, it will continue in the circuit. Okay, so what is happening here? You can see that gradually the electron which has been transferred like this is coming at the higher potential, and it is getting accumulated at the higher potential, right? So I can say that the potential of the higher terminal will decrease because electrons are getting accumulated. But no, inside the battery the electrons will now move from this to this. The electron will move from here to here, and therefore the potential is maintained. The charges are maintained at the end of the cell. Okay, that is the internal mechanism of battery. But overall, if I discuss what is a battery is a source of energy, not a source of charge. Is that clear? So if assertion and reason question is asked and the question says, or the option says that the battery is the source of charge, that's the wrong answer. Okay, even the battery is, the function of the battery is simply to maintain the charges, to maintain the potential difference. Got it? Perfect. Now let us say that this is a battery. Okay, you will find that this region is, let's say, having a potential V1, and let's say this region is having the potential V2, and let us say that the EMF of the battery is 5 volt. EMF of the battery is 5 volt. So what you can see from here, that if the battery is having an EMF of 5 volt, I can say that since this is the longer side, so I can say this is the positive terminal and this is the negative terminal. What does positive and negative terminal means? Well, positive terminal means that this is the higher potential here, and this is the lower potential. This is the lower potential. Got it? Understood this? Okay. Now the another thing that I can discuss here is that what is the value of V1 and V2. So remember what I said, that delta V always remains a constant. Delta V cannot change, but V is based on the reference. V is based upon the reference. Okay. You cannot have any fixed value for the potential. You can have a fixed value for the potential difference. In all these cases, you will find that the potential difference, since it is connected by a battery of 5 EMF 5 volt, so the potential difference across the ends here, that will be 5 volt. The potential difference across the end, that will be equal to 5 volt. Okay. Delta V, that is V1 minus V2, that is equal to 5 volt. Okay, I understand that. So what is the value of V1 and V2? Well, they are not having any particular value. They could have the possible value. Now what are the possible values for this? So you can find that V1 can be 5 volt. Okay, so this is higher potential, so this will have the higher value. So this is V1, which is 5 volt. So V2 will be what here? V2 will become 0. Only then the potential difference is maintained 5. V2 can be your 10 volt. So if V2 is 10 volt, V1 is your 10 volt, I can say V2 is 5 volt. Okay. You can find here that still the potential difference is the same, that is 5 volt. That is what required. You can have V1 as 15 volt. Okay, while your V2 will be how much? That will become 10 volt here. Okay, even if you wish, you can take V1 to be 0 volt. If V1 is a 0 volt, what is the value of V2? V2 will become minus 5 volt. You can have your V1 as minus 100 volt as well. So what will be V2 in that particular case? That will be minus 105 volt. Okay, so it's up to you that how do you wish to have that. Okay, if you wish to have the value as simply 0 and the another E, okay, so you can have that also, and whatever you wish, you will be given there. Okay, I'm repeating this thing again, that potential difference is the same, that is 5 volt, but V1 and V2 can change here. Got it everyone? Okay, perfect. So this was the introduction about the battery. Okay, let me discuss one more case so that let us understand whether you understood this or not. So the battery is like this. The EMF of the battery is given to you as 6 volt. Okay, now I am asking that if this is given as 6 volt, can you let me know everything about this? Okay, let us say that these are the 2 points here. Let us say that this is the point V1 and this is the point V2. Tell me everything related to this. Okay, I hope you have read this. So I can feel that since the longer side is toward V2, so I can say that V2 is at the higher potential and V1 is at the lower potential. The EMF is how much? The EMF is 6 volt. So if you go, hear me out carefully, okay? If you are going from the higher potential to the lower potential, EMF decreases, therefore this will be minus E, okay? This will be minus E. But when you go from lower potential to higher potential, actually your potential is getting increased, right? So this is your plus EMF. Are you getting this, what I'm trying to say? When you are going from V2 to V1, when you are going from V2 to V1, what you can find from here? You will find from here that it will be V2 minus EMF. Okay, what is the value of V1? V1 will be equal to E2 minus EMF. Why I have done this? Because I am decreasing the EMF from the potential. As I am going from higher to lower, the value is decreasing. Therefore, what I have to do? I have to decrease EMF from the V2. Therefore, V2 minus EMF, that is equal to V1. And now when you calculate V2 minus V1, that is equal to EMF. Got it? Okay, what is the next thing here? The next thing is that what happens if I go from V1 to V2? So when you are going from V1 to V2, actually V1 is being added with EMF. Okay, when you add the EMF to V1, you get the value of V2. Now why I am adding the EMF here? I am adding the EMF because I am going from lower potential to the high potential. So that will cause increase in EMF, right? So this will be V1 plus EMF, that gives me a value of V2. Okay, so now if you do V2 minus V1, that is again EMF. In both the cases, change in potential is same. Okay, but the values differ according to our reference. Got it? Okay, if I simply say that if I just ask you that the value of the V1 is, let's say, okay, let me take an example. The value of V1 is given as minus 8 volt. Find the value of V1. Sorry, find the value of V2. So how will you find V2? What I can do? I can go from V1 to V2. So when I will go from V1 to V2, minus 8 volt will be added with the EMF. That is minus 2 volt because you are going from lower to high potential. Instead, if you are going from V2 to V1, if I am going like that, so you will find that V2 minus the EMF, that is 6 volt. This will give me the value of minus 8. So this will give you a value of V2 is equal to minus 2 volt again. Okay. So the answer remains the same. That is upon B. That is upon us. That how do we proceed? Okay. Got it? Okay. I hope that is clear. So if you got this, let's have a quick round. Okay, I'm just giving you the questions in rapid manner. Okay, you have to solve them and you have to tell that what is the value of me. Okay, so this is a battery. Okay, the EMF of the battery is given as 6 volt. This is given as minus 8 volt. Find the value of V1. Okay, continue doing it. I will discuss the answer at the end. This is V1, this is V2. V2 is given as minus 7 volt. Okay, and the EMF is given as 4 volt. Okay, the next question. This is the cell here. This is 3 volt. This is your 8 volt. Okay, find the value of the EMF here. Okay, 4. This is given the cell like this. This is your V2. This is your 8 volt. This is your EMF of 8 volt. Okay, you have to tell that what is the value of V2 here. And the fifth one, that this is something here. This is your V2. This is your V1. Okay, this is your 4 volt given, and the EMF is 2 volt. Find the value of V2. Okay, just try this. Okay, once we will be discussing about the battery, then we are going to start with the capacitor. So please pause the screen for a while. Try all the questions so that we can proceed further. Okay, let me help you. So we are given the value of 8 volt here. Okay, so I can say that this is high potential, this is lower potential, right? So when I will go from higher to lower, you will find that you are going from positive to the negative terminal. And what does positive to negative terminal means? That means that potential is decreasing. Therefore you will write minus 8 minus EMF, that is 6, that is equal to V2. So V2 is equal to minus 14. V2 is equal to minus 14, and this is justified as well. You can see that minus 14 is less than minus 8, right? So what is the value of V1? V1 is your minus 14. Okay, next one. So here you are given that this is the higher potential here, this is the lower potential here. Okay, so let us say right now I am going from lower to higher potential. So when I am going from lower to high potential, this is my negative, this is my positive. So you are going from the negative to the positive terminal, that means potential is increased. Therefore lower potential, that is minus 7 plus the EMF, that is the value of V1. So you will say V1 is equal to minus 3 volt. V1 is equal to minus 3 volt. Got it? Okay, try the next one. So here you are given the end potentials here. Okay, this is the lower one and this is the higher. Okay, so let's say I'm going from lower to higher. So when you are going from lower to higher, your EMF will be positive. So you will say 8 plus EMF, this is equal to 3. So when you will subtract this, you will get 3 minus 8, that is minus 5 volt. So what is the EMF here? Minus 5 volt. EMF is minus 5 volt. Got it? EMF is minus 5 volt. Now let us talk about this. So here this is the lower potential, this is the higher potential. Okay, and this is 8 volt. Okay, and this is also given as 8 volt. So let us go from the lower to high potential. So definitely your potential is increased. So you will say 8 plus 8, this is equal to V2. Therefore V2 is equal to 16 volt. V2 is equal to 16 volt. Okay, fine. The last one. Now you are having the EMF 2 and this is your 4 and this is your V2. Okay, this is your definitely lower potential, this is your high potential. Let me take it like this. Okay, if I'm going from higher to lower potential, I will say V2 minus 2 volt. Why minus 2 volt? Because you can easily observe that you are going from lower to higher, so your potential is decreased, so minus 2. Okay, this is equal to 4 volt. Therefore V2 is equal to 6 volt. Got it? V2 is equal to 6 volt, that is answer. Perfect. Understood how to get this question and how to find the answer to this? Perfectly alright. Okay.
The problem is not effort. It's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.